Today we're going to talk about absolute value equations, and I really should have said functions there. So we're going to both graph and write absolute value equations, which I really should have put probably functions, because these are going to be y equals. Okay, to warm us up today, we're going to evaluate some things that have absolute values to make sure you remember what they are. So the absolute value of 12 is just 12. However, when I take the absolute value of a negative number, so negative 5, it's a positive 5. Because the definition of an absolute value is the distance from 0, and the distance is going to be positive. Even in this next one where it's 2, and then the absolute value of negative 3, think about that an absolute value as like parentheses. We need to do that first. So this would be actually like 2, and the absolute value of negative 3 is a positive 3, so the answer to this would be 6. Okay, this one's a little different because this time you're taking the negative value, the negative of the absolute value of 19. So we'd still have a negative out front, but the absolute value of 19 isn't positive 19, so we get a negative 19 as an answer. Last but not least, this one you'd have a negative 3 out front. The absolute value of a negative 2 is a positive 2, so we'd get a negative 6 as an answer. Okay, so introducing the absolute value function. So f of x equals the absolute value of x. To graph this function, let's complete the following table, and then we're going to plot some points. So if I ask you what is the absolute value of negative 3, we kind of just went over this, we get a positive 3. The absolute value of a negative 2, we get positive 2. Absolute value of negative 1, we get 1. Absolute value of 0, we get 0. Absolute value of 1, we get 1 again. Absolute value of negative 2, we get positive 2. Absolute value of negative 3, we get positive 3. So if I start plotting these points, negative 3, 3, negative 2, 2, negative 1, 1, 0, 0, then we get 1, 1, 2, 2, 3, 3, you'll notice your graph makes this V shape as I connect the points. If we continued on, right, you could see more of what it looks like. All right, so let's talk about some key characteristics of just your generic absolute value graph. Notice here with our absolute value, the vertex, right, meaning the minimum or maximum, in this case the minimum, the low point, is at the origin, so it's at 0, 0. As you think about the slope, I think this is the other key characteristic. So it makes this, I guess maybe I should also put like, hey, it's going to do a V shape this time rather than a U shape for a parabola. And then the other thing is the slope is key. So if you look here, we're going up 1 over 1, up 1 over 1. So the slope is a positive 1 on the right, and on the left, because it's going down, right, you can think about it going down 1, right 1, down 1, right 1, is negative 1, right? So depending on which side you are, positive 1 or negative 1, it's always going to be that generic slope. Today we're going to look at how transformations impact the absolute value function. So let's see what we remember. If you negate the function, so you have y equals just a negative absolute value of x. Think about that. That changes all your y values. So that reflects over the x-axis. So if you simply had y equals negative absolute value of x, rather than it being an upwards u, so remember this is your original, that's helpful, you would now get a downwards u. Sorry, v. We have a v here, not a u. Okay, a, remember this is going to like change, right? If a is greater than 1, we get a stretch. And if a, I should say if like a is less than 1, but really it's if a is between 0 and 1, you get what they call a shrink. So the stretch makes it taller, right, or skinnier. The shrink makes it wider. Okay, in this case, what it's going to impact, it's going to impact the slope. And I think that's a key thing to kind of recognize here. So if we have y equals 2 times x, we think about our original absolute value, making that v, Your new one will now have a steeper slope. So it'll have a slope of 2, so it'd be steeper, right? Or taller, however you want to think about it. Like something like that. Okay. Let's go ahead and take a look at the next one. H. So remember, it's inside the parentheses. Thinks about your vertex form. Anything inside the parentheses moves things horizontally. So if you have something that is negative, you have a negative H. Remember, this one goes the opposite direction in the parentheses. You could say insiders lie is a little trick for you. This moves it to the right. I'll say moves the vertex to the right. So opposite, if you have a positive, it's going to move the vertex to the left. Okay, so x minus 3 is going to move it to the right 3. So on your graph, you'll still have that V shape, but rather than it being at the origin, you would have the vertex at a positive 3. Still the same slope and everything, right? But it's just going to be moved to the right. Maybe here I should have put like steeper slope of 2 now. And then this reflect over the x-axis. Okay, last but not least, if you add k at the end, that's what moves it up or down. So these are what we call like a horizontal and then a vertical shift. So if this one's negative, then it moves the vertex down. So it moves the vertex down. Goes the way that you expect it. And if it's positive, it moves the vertex up. So here when you have the absolute value of x plus 1, that's going to move it up 1. So think about your original absolute value, and now we'll have at 1, we'll have the graph. Slope hasn't changed, but it's simply moved up 1. We're going to go ahead and use that knowledge to help us graph. So in general, remember it's going to make this V shape. Usually it's at the origin unless it's shifted, and the slope of like the two sides are 1, and then it reflects it or a negative 1. Okay, so the graph of the absolute value function. So we're going to graph the following. This 1/3, right, is they tend to call it a shrink, right? And so it makes the slope now 1/3. Notice we haven't shifted right or left at all, so we still have it at the origin. But now we're only going up 1 over 1. We're going up 1 over 3. Up 1 over 3. Up 1 over 3. You can think about this other side as two things. You could say, okay, well, it's going to go up 1 left 3, up 1 left 3, or you could just think of it as a reflection. So reflected over the y-axis would be your other way to think about it. Okay, this next one does two things. Remember, insiders lie, but this is going to go horizontal, so this goes left 3 and down 4. So your vertex now is left 3, down 4, so it's at 3, negative 4. We don't have anything out front, so it hasn't reflected. We haven't changed the vertex at all. So your slope is just 1, up 1 over 1. Your left side, you can go up 1, left 1, or you could just say, okay, it's a reflection across. Now, the axis of symmetry goes to the vertex of that line there that I just drew in. Okay, here we go. We got our absolute value graph. Okay, this next one has done a couple things here. Okay, so the inside moved it to the left 1. The outside of plus 5 moved it up 5. This negative reflects over the x-axis. And this is like a stretch, right, of 2. So that means your slope now is going to be 2. Okay. I could start by thinking about the vertex, left 1, up 5. Usually you'd say, okay, the slope is 2, right? So we go up like this, but this time, remember, since it's reflecting, it is not going up, right? It's going to go down, just as a kind of a key idea there. So our slope here will be positive 2 on the left side, and it will be this negative 2 on the right. So it still goes down 2 boxes over 1, right? Or up 2 over 1, but it's going to go in the downward direction this time. So we get something like this. Okay, last but not least, this one goes down 2 as the outside. Insiders lie, so the opposite of a negative 7 is a positive 7, so it's really going right 7. And then once again, we've got the stretch, a vertical stretch of 4. So that means that the slope is 4. Okay, right 7, down 2, it's my vertex. And then I'm going to go up 4 over 1, up 4 over 1. You can think about the other side as a reflection from that vertex, where you could go up 4, left 1. So this one is really steep this time, right? You're going to get an absolute value graph like this. Okay, the last part of the assignment today is we're going to be looking at writing the equations of these absolute value. So I would start by just identifying the transformations, like identify the vertex and identify if anything's happened out front. So like, is the slope different than 1 or not, is maybe reflected. Okay, so our vertex here, we went left 1. We also went down 4. You'll notice the slope, I go up 1 over 1, the slope is still 1. And it hasn't reflected, so there's nothing going on with the a or like a negative out front. So here, when you write y equals the absolute value, the left is going to go inside the parentheses, and it's the opposite, so rather than minus 1, it's a plus 1 for going left. But then down 4 is outside your absolute value. We will subtract 4. Maybe here when I write this, give me 1 second, I'm going to just make these absolute values a little more obvious. X plus 1 minus 4. Okay, let's look at this next one. This one, the vertex, this time we went left 2. We've also gone up 3. And this time the slope doesn't look like it's the same, right? We're going up 1 over 2. Up 1 over 2. So the slope is a half. Okay, notice I usually just focus on the right side because the positive slope's a lot easier to deal with than a negative slope. So this time there is going to be a number outside the absolute value. It's a half. Then we're going to have our absolute value. Going left 2 is x plus 2. And then up 3 would be outside the absolute value. We have a plus 3. Okay, let's look at this next one. This one went right 4. It didn't go up or down at all, so we're going to have nothing adding or subtracting at the end. This one did reflect over the x-axis, right? It's going down rather than up. And the slope also doesn't look the same. Let's see if we can see the slope. So here you could say it's down 3 over 1. Or it's probably easier to look at the left side this time to go positive, up 3 over 1. So the slope is 3. As far as the negative or positive, the only reason why your a value up front would be negative is if it's reflected down. Besides that, even if you count the slope as negative, still put the positive out front, which is a good point. So here we get y. Your slope, we are going to put a negative 3 because the negative represents the reflection, and then the 3 was the slope. To go right 4, we're going to do x minus 4 inside the absolute value. We said that we're adding nothing in the end because we didn't go up or down at all. Okay, that's it. Good luck with your assignment today.